So as we're looking at my notes from high school on the other side of the handout number 1, we've got another discrete random variable this time. What are the values that variable takes on? I don't know what it is, but like, what are the values it takes on? 2. You see it? You should be looking at it. 2 and 3 and 4 and 7 and 9. Those are the values that are possible for whatever this is measuring. I should have defined what it was, but I didn't. So sue me. Okay? Let's write down how to compute the expected value for that. So I'm just going to write it down here. So x and the probability of x. So we said 2 and 3 and 4 and 7 and 9. Those are the possible values x can take on. For some reason, the possible probabilities, the chance of getting 2 is 20%, getting 3 is what, 10%, 10%, 40%, 20%. These should all add up to what? 100%. If they don't, you did something wrong. Okay? Can't have more than 100%. So we're going to look at the expected value of x first. That's what we're going to talk about today. So you need that for your assignment. What's the expected value of x? In other words, what x do you expect on average to occur? Another way to talk about this, if these are all the different possibilities that can possibly occur, this is actually mu. It's the parameter, as long as you have all the things that can possibly happen up there. That's an elusive quantity to calculate this year. We're going to be working with, trying to get it often. But if these are all the possibilities, then that's truly mu. So how do you compute that? Well, the formula is the sum of each x value. I like to call it x sub I. I think that's what I called it in high school too, yeah. And you attach the probability weight of each x sub I onto it, because that's going to show how likely each one of those x sub i's is. Then you sum it up because you see how much each probability contributes to the overall expectedness. Okay? So doing that is very simple. You can do it by hand or by calculator. I have a nice little technology tip off to the side there that I wrote down in notes too. So we'll go over how to do it in our calculator too. How do you do this by hand? Well, you do each one. First x is 2, 20% chance of that happening. Plus 10% chance of 3, plus 10% chance of 4, plus 7 has a 40% chance, 9 has a 20% chance. What did I get? 5.7. That's the expected value of this random variable, whatever it's measuring. How do you get the spread? A good number for spread is standard deviation. Before you can ever do standard deviation, we work with variance. So a lot of the formulas in this section are going to be doing variance. But it's just spread. Keep that in your mind, spread. It's how spread out that random variable is. Okay? So variance of the random variable x, this random variable x, whatever it is going to be the sum of each value x, how different it is from the expected value, or the mean, squared, and then the only thing that's a little bit different than what we did before is we attach the probability weight here. But you should be expecting the probability weight to come in somewhere, because it has an obvious effect on what happens with the variable. Okay, so that's what we need to do. You can of course do it by hand, but it's a pain by hand. You can do it though. I'm going to write it out a little bit like I have on there. So the first x is 2 minus the average we got. You have to do that first, is 5.7. Square that guy and multiply by what? 0.2. Thank you, Lauren, whoever said that. Then you can do the next one, and you can go 3 minus 5.7 squared times 0.1 plus, I'm going to have to do 3 more. What's the answer I got supposedly on there? Variance was, oh, did I not write it out? Oh man, I didn't write it out. Shoot. I guess we could do it the long way. I don't want to do it the long way though, guys. So how do we do this the short way? Let's go to our calculator. This is how I expect you to do it on the assignment. I think it's good to write it out a couple times. So find at least one problem where you do it the long way. Just one problem at least, okay? Let's do this guy the short way though. So the technology tip says, enter these in list 1 and list 2. Okay, well, we're used to that. So in list 1, I'm going to put my values of the random variable. In other words, 2, 3, 4, 7, and 9. I'm going to put my probability weights in list 2. And if you run 1 or 2 variable stats, you get means and standard deviations. The question is, this is where lots of students get confused because they're not thinking. Do I want to run 1 variable stats and get the statistic information for 1 variable, or do I want to do it for 2? So a lot of students are going to say 2 here because they're like, well, there's 2 lists. But how many variables do I have? 1. I have 1 variable, and how likely that variable is to occur in list 2. So go ahead and hit stat, calculate 1 variable statistic, because we only have 1. Except instead of just hitting enter here, you guys sometimes have a menu pop up, I know it's nice. Hit list 1, because obviously that's the variable, comma, list 2. What that's going to do is it's going to put list 2 as the frequency. Frequency is another name for probability if you add the word relative. That's what we saw in the video yesterday. So if you do that, it'll take and find all the information for list 1, with list 2 being its frequency or its probability. Okay? And where's our expected value on here? Right there. Now it called this x bar instead of mu. The calculator's not smart enough to differentiate between statistic, which is x bar, and parameter, the real thing, which is mu, because it doesn't know this isn't just data. It doesn't know this is all the data that exists. Now that's a big distinction that I'm going to keep hammering out all year. If you get it by the end of the year, you're good. If you're not getting it completely yet, that's okay. We're going to see it in lots of other forms. But also, I've got the standard deviation here. Oh, I don't have SX, but I do have this guy. So you guys can use this guy as the variance. So that's what that number that I was trying to compute here would come out as. Okay? So there you go. You've got the variance. Oh, excuse me. I guess if I wanted the variance, this is the standard deviation. How would I get the variance? I'd have to square it. Exactly. Very good. So if I squared that, I'd get the variance from a second ago. All right, let's look at one more problem. We're going to call it a day because this has been a lot of intenseness. But this last one I think is super cool. So I know we're all tired, but hang in there. Let me pause this. Okay, so let's look at that one with computers, and we're worried about sending out refurbished computers, and we're worried about how much money we're going to lose on average. So first of all, what's our random variable? Call it x, y, whatever you want. If you don't define your random variable, you're always going to lose in this kind of math. So make sure you do. X is what? Controls everything that we do. What are we worried about? Money. So be more specific.
Lost money.
There we go. The amount lost. Got it. Okay, so the amount lost. So now we need to think about what could possibly happen to us. So what could possibly happen to us? So X, and then we're going to have to figure out how likely each one of those things that could happen to us is. There's a few different possibilities. What could happen? Vance was already summarizing when he talked about it a second ago. You could get 2 new computers, in which case, remember, we're not keeping track of computers here. X is not computers. It's how much money we lose or win. Or don't lose, I guess. Can't win money here. They already paid us. So if we get 2 new computers, what's that mean in money, Brandon?
You don't lose it.
No payment. Great. 0. If you want to write in your notes, though, that means 2 new computers. Great. We could also end up paying them what? $100. That's if they get what? If they get 1 refurbished one. I've had this happen to me. I got a refurbished computer screen one time. I was kind of mad.
Excuse me, Mr. McGee?
Yeah. Yeah.
Nate Carson and McKenzie trying to find out.
All right. Okay. What if they get 2 computer screens that are refurbished or whatever? We lose a lot of money. Is there any other possibility? No. If you're thinking, but like, they could get 1 refurbished a couple different ways. You're right. But that doesn't affect that we pay $100, right? So there's only 3 possibilities here. The question is, how do we come up with the probability weights? You guys tell me. A tree. Yeah? A tree with the first set of branches controlling the first computer we get. So what are the numbers here? Do we have 15 total?
Yeah. Four. Yeah. 11.
So we got 11 out of 15 that are new, and 4 out of 15 that are refurbs. And then we're going to have another computer, but either one of these things could have happened, right? So this was a conditional probability. This will be taped, guys, if you want to see it. But
Okay, thank you.
if you want. Okay, so if we picked a new one, I think these probabilities change. What's left here for new refurbished? 10 out of 14. So then this is 4 out of 14. If we have a refurbished one that we've already gotten, that means how many of those are left? 3 out of 14. So then this would be 11 out of 14. Oh, did I mess up? I did. Em was right. I mislabeled that. 3 refurbished ones are left. Hopefully that doesn't happen. And 11 of these are left. Sweet. Nice. So now I need to multiply along the branches to see what happens. How many outcomes are there? There's 4 outcomes. There's only 3 values of the random variable. Make sure you're clear about that, right? So this is what? Can you guys multiply those for me? See what you get? This one, and this one, and this one. Let's see. What do we get for each one?
Your first one you get
0.52 for. And the second branch, 11/15 times 4/14. Is that going to be right?
No. Yeah.
I haven't learned anything about math if I do that. I've got to make sure I put fractions in parentheses, right? So like, no, it's not going to work. Just making sure you're awake. What's this one?
0.20.
Yep, thank you. And the bottom one, 0.05 something. I think it was like 0.06. Okay, so those should add up to 1. I mean, there might be some rounding issue there, but I think they're going to add up to 1 pretty much. Okay, so now we can use those to fill out our discrete chart. So, which ones of these do we pay nothing? New. That's the only possibility. That's good. I mean, 52% chance we pay nothing. That's not bad. Coin flip, pretty much. All right. So then we pay 100. What do I have to do for 100? Add up this one and this one, because each one of those has 1 refurbished in it. So that's going to be what? 0.42. And then refurb is only 6% chance. That's good. So even just looking at that distribution of that discrete random variable, we can kind of see what's going to happen to us, but we can boil that down to one number, one statistic, which really makes it nice and clear. So what's that one number going to be? The expected value. Now, of course, we could do it long ways. We could go 0 times that is nothing. So really, this long ways is pretty easy. It's going to be that plus that, right? The variance, let's do it long ways on this one just to check, okay? So the variance is going to be, well, I need that number first. You guys have it? I think it's, I got $102. You guys want to confirm me? So on average, it looks like we're going to have to pay $102 in this scenario due to Bob in the copy room, his poor job performance. Shipping out those computers. Yeah, so this is what we might charge Bob right away. Anyway, the variance is going to be 0 minus that 102 squared times 0.524 plus, let's see, 100 minus 102. You guys get 102? Don't trust me. That's the number I got in high school. You don't trust me in high school. Run out of room. Oh, I could go like this. Ha. Let's see. You guys got 102 though?
Yeah.
Yeah, okay. Just double checking. I don't trust me from high school. You don't have to do all of yours this way. I just want you to do like 1 or 2 this way. You'll really understand it a lot better if you do. What? Oh. What am I missing? I can see something right away. Well, let's see. Nope, I don't see it. I think that's it. That's a huge spread of possible outcomes. The thing is, that's the variance. It's not the standard deviation, which is our general way. So we have to take the square root. So the standard deviation of x is going to be the square root of that. That's not a very meaningful number in and of itself. Hopefully this makes a little more sense. Yeah, there we go. That makes a lot more sense. So the standard deviation is the more convenient value to measure spread that actually makes numerical common sense. Variance is how you get there though. So all the rules are stated in terms of variance, not standard deviation, okay? So this is a pretty good spread, isn't it? I mean, on average we're gonna have to pay $102, but it's pretty likely it could be a little more than that, right? Because just one standard deviation above is like $300 some. So spread on this guy is pretty significant. Have we answered all their questions? I think we have. Let's just double check that we get the same answer the short way. So I'm going to go my short way. Stat edit. And let's see. The short way, we're going to go 0, 100, 1,000, 524. Stat, calculate one variable statistics. List 1 with list 2 as the frequency. I think I might have some small rounding issues, but you get the point. AP exam doesn't care about rounding issues. Okay? So, try to do 1 or 2 by hand. You can do the rest with one variable stats. Be like, I'll see you next time.